video we'll look at the M-TEST tool. Bit of background first. If we go to the baseline tool, this map shows the distribution of faunal communities within the South Coast region, and what we're trying to do is to make sure that these patterns can exist after dredging by making sure that the habitat within dredging areas is maintained within certain limits, so that the original animal communities can come back. And we're judging whether habitat conditions remain acceptable using something called an M-TEST, and details about that can be found in the paper, which can be accessed through the About tab, and you click on the link there, and then in that paper you'll find a description of how the M-TEST works. So the aggregate industry is undertaking regional monitoring under the Regional Seabed Monitoring Programme once every 5 years for each dredging region, and these black dots show the sampling stations for the South Coast region. So what the industry does is it goes out, it collects grab samples at each of these points, and then looks at the sediment composition for each sample. And in the M-TEST tool, we're looking at the sediment data and asking whether the sediments remain suitable to support the return of the original assemblage after dredging. And so just before we go any further, it's probably just worth looking at the data which will be brought into the tool, and it looks a little bit like this. So there's two options. One is to put the data in manually, and one is to use a file upload, and this is the format of the data in the file for uploading. So in the first column you've got the RSMP station codes, and then to the right of that you've got sediment composition from coarse gravel, medium gravel, fine gravel, coarse sand, medium sand, fine sand, silt clay, and this is the percentage of each of those fractions. So just to very quickly look at the manual approach, so if you wanted to look at one station at a time, you could use this. So you select your region, you select the sample you're looking at, and you can put in some data by typing into these boxes, and I'll just use some dummy data. And once that's all in, you can press the M-TEST button and it'll go away and perform the test. So the way it works, if we just go back to the baseline, is that let's imagine our monitoring station at the baseline belonged to the yellow group. What the M-TEST does, it looks at the sediment composition of all the yellow samples, and so that gives us an idea of the natural variability in sediment composition associated with that group. And the M-TEST will look at the sediment data for our single monitoring sample and say, is it part of the wider distribution for all the yellow samples? And the answer is yes or no, and that's decided with a p-value. And if it's okay, then that means that you should be able to get a return of the original faunal group after dredging. If it's not, then the sample is flagged. So with so many stations within the RSMP array, you probably wouldn't want to do that sample by sample. You'd want to upload the file, and so the way that you do that is just to select file, select your region of choice, and then you can point to the file to be uploaded. So there's my file, and when it's uploaded you'll get a blue bar telling you that you're okay to proceed, and then you can press the M-TEST button. Before I do that, we'll just look at the map briefly. So again, you can turn on lots of different layers here. So you've got the primary impact zones or license areas shown at the moment. We can look at the secondary impact zones on top of that. We can look at the RSMP stations in the full array, and then you can look at your M-TEST results. And if I just perform a test now, then we can turn these things back on again, you'll see that the table here populated. So in 2017-18, the stations in the array which were sampled are those ones which now have a green or a red box around them. And if the sediment composition passed the M-TEST, the Mahalanobis test, then it gets a tick. And if it failed the test, then it gets a flag. And if it gets a flag, it doesn't necessarily mean there's a problem. It just means that there's further investigation is required. There are all sorts of reasons why sediments might change. Natural changes, other activities. You may have sampled in a slightly different place, and so there'll be a process of trying to identify the cause of any flags, and that has to be done outside the app at present. So over here on the right hand side, you've got all your stations in your array, and this is the results of the test. So it's either a pass or a flag. You'll see on page 2 some of those samples were flagged. You can then go and look at the flags in the second tab, and so what this shows is the nature of the problem. So it gives you an idea of why individual samples have been flagged, and what we're looking for here is the highest numbers. This is where the most likely cause of the failure, test failure, is. So in this case, we've got much elevated levels of coarse sediment, and that contrasts to the samples down here where you've got the opposite. So these samples become a lot finer. And so these numbers are basically worked out according to the formula in the paper. If I just go down to the relevant table, yeah. So basically what we have is our one monitoring sample, and then we have all the other samples, many hundreds typically, of the same group. This is giving us an idea of the natural variability, and this is the means for all of those samples. So this table provides an example of how the test works for an individual sample. So we've got our test values, we've got our means for the wider group, and we're just following this equation here. So we're subtracting the means from our values and then turning them into percentages. So for this particular sample, it's an elevation of the fine sand fraction, which is causing the flag. So this information can then be used. Well, first of all, you have to decide whether the flags are significant and dredging related, and then if they are dredging related, then this is some useful information to allow industry to try to make sure conditions come back within the acceptable range. And that may not require any intervention. It may happen naturally, but those are decisions which have to be justified. And then in the final tab, there are some statistics. So in this survey array, there were 506 stations sampled, 92% of which passed, and 80% were flagged. And then you can see a breakdown of that information by treatment group. So the context ref samples are those stations outside the footprint of dredging effect. The PIZ are the stations within the license area, and the SIZ are the stations within the secondary impact zone. And these graphs and the table just provide a summary of the results. Thanks for listening.